Hey guys, welcome back to Level 4 for another great episode. We're going to be talking with our friends from Mathworks. I'm Mike Sorg, the podcast and a video producer with the SAE CDS series. Excited for another episode here. We got a whole crew with us on the line from all over the place calling in this week. First, we have Lauren Tabolinsky, the academic program manager at Mathworks. How you doing, Lauren?
Great.
And also we have Sam Reinsel, the application support engineer at Mathworks. How you doing, Sam?
Pretty good.
And Mark Corless, the automated driving segment manager at Mathworks.
Good. Happy to be here.
Mathworks has been involved with Autodrive for a while. So before we get into a lot of the questions, how has it been so far kind of to be part of this process for the Autodrive challenge so far for you guys?
So it's been really exciting and challenging. We have a great team of engineers here at the Mathworks who are involved in helping the students. And we're learning a lot from the students as well. And they're challenging us and giving us great ideas on, how we can make our products better and how we can help them longer term so they can become, future engineers that work in industry.
Yeah, it's fun hanging out with the students. They're very optimistic, and it's nice to see like a hungry set of minds ready to tackle these big challenges that the entire industry is facing. So it's good times.
I was actually a student back when I think the year one of the competition was happening at Virginia Tech. So it's been interesting to kind of transition from kind of knowing people back during the very first year of the competition to now working to support the student competitions from the Mathworks side.
The big topic for today, of course, is MATLAB and Simulink. Before we get into the details, helping the students out that are involved in this now, can you kind of give a brief overview of what those products are for those that may be checking this out for the first time and seeing what the competition's about?
Yeah, sure. So MATLAB and Simulink are pretty broadly used in automotive in general. MATLAB is kind of this base platform, and a lot of what we see here is engineers using that both from a data analysis point of view as well as for an algorithm design point of view. So, for example, some things that are common in general automotive applications as well as automated driving is this notion of just bringing data into MATLAB and visualizing it and analyzing it to gain insight. One of my colleagues in the industry likes to call this bringing life to the data because there's just so much data out there and you're trying to understand it. You need an environment where you can look at the data and you can bring life to it and understand it. One of the reasons that I see engineers choosing MATLAB in the automotive industry is that it's really easy to access some of the common data formats that we see in automotive. So, for example, logging data to CAN formats, CAN MDF formats, or accessing live CAN data. This is really common in the automotive industry, and MATLAB has been able to connect to that and work on that type of data for a long time. On the teams that are starting and companies that are starting to look more at the autonomous side of things and prototyping, then you're seeing them use things like ROS, the robotics operating system. This is another type of technology that MATLAB integrates very well with. So it's easy for them to get that data into MATLAB. MATLAB has a lot of tools for plotting data, has a lot of tools for building custom apps. It's really for that engineer that wants to look at their data and gain some specific insight from that. Now, once that data is inside of MATLAB, a lot of times it's that same engineer, a lot of times will actually start using that insight in order to design different algorithms. We see this on the perception side. So maybe taking data from a camera or a LiDAR or a radar and trying to detect objects or trying to estimate the velocities of things around them. Taking the outputs of all those things, designing like sensor fusion algorithms. So we see a lot of engineers using MATLAB as an environment to fuse the output of different perception algorithms together. And again, this is an area of a lot of active interest in the automotive community, and there's a bit of engineering behind it, and there's a little bit of art. So customers that I talk to want to have an environment where it's very easy for them to play and explore. If I look a little bit outside of the automated driving area, one of the things that I see customers using MATLAB for is just to go through a lot of the data that was recorded from their fleets. So there's a lot of companies have big amounts of data from their fleets, and what they want to do is parse through that data. They want to find different events, and then they actually want to create mathematical models for the way that this data is created. So sometimes in industry you might hear this term like digital twin. So they maybe use MATLAB to design this digital twin, they'll put it up on the cloud, and they can use that to actually predict failures in the vehicle before they actually occur. So that's kind of the MATLAB, some of the MATLAB use cases. But you asked about MATLAB and you asked about Simulink. So let me talk a little bit about how Simulink kind of builds on top of all that. So Simulink in the automotive industry is pretty broadly used to design, simulate, and deploy embedded software. And this is really taken a hold in like the controls applications where closed loop design is important. Applications where customers need to model the vehicle dynamics, model what sensors are doing, model what road conditions are doing to be able to kind of gain this insight in the simulation environment before they ever get to the vehicle. Within this environment, once we see customers designing like the controls and decision logic, a lot of times they'll take that same code and they'll generate C or C++ code. They'll use that for rapid prototyping. They'll use that as part of their production process. They'll use that in part of their ISO 26262 verification process. So we see how Simulink has this complete environment where people can go from idea to simulation to prototype and production. One of the nice cases that we have that maybe the students could look at is we have this user story from Voyage. So Voyage is an autonomous taxi company, and they are working with retirement communities. And they designed some of their controls and decision logic in MATLAB. They generated C++ code, and they generated this ROS code. And from this ROS code, they could integrate it with the rest of their ecosystem. And it's a nice example of how Simulink is really helping them accelerate their design process. If I go back to that user story, that's a user story all about designing something in Simulink and generating code out of it. What I also see from customers is they have a lot of hand-coded components because there's a lot going on in the autonomous systems area. What they want to do is bring that code into Simulink and run a system-level simulation in order to gain insight. But if I try to summarize all of that into a couple of sentences, MATLAB and Simulink really help engineers gain insight from their data. They help them design their algorithms and assess performance in simulation, as well as help deploy those designs for prototyping and for production.
So if I do have questions about errors or product usage, where can you go and get help from MathWorks engineers?
That's actually something that I did in the last year and a half. The tech support group at Mathworks is made up of a bunch of different engineers with a pretty broad background, and with the licenses that all the teams have sponsored for Autodrive, they do have full access to the Mathworks technical support team. It pretty much varies everywhere from computer science backgrounds to mechanical engineering like me, or there's a couple of civil engineers who have a lot of experience with MATLAB and Simulink. So if you're encountering any sort of error that isn't clear, like what's actually wrong, or there's something in the documentation or an example that doesn't make a lot of sense to you when you're looking at it, or there's just like a function that you're trying to use it, maybe you're trying to understand how the input and the output actually works in practice. All of those are kind of things that tech support can help you with, and you can get in touch with them by email or over phone. You can find both of those on the Mathworks website. There are some things that they can't help you directly with. They're there to help you get your work done. The tech support team deals with a lot of our industry customers, whether that's GM or any other automotive company that uses MATLAB and Simulink. They pretty much every day will call in or send an email to the tech support team. So the goal really is for tech support to help our customers get their work done. So it's not tech support can't like write code for you or debug every line of code with you, but the goal is really like if anything isn't clear or you're getting an error that you're not sure how to resolve, that's something that tech support can help you with. For more like competition or application related questions, we do actually, the student competition team has two different groups, the racing lounge and then the robotics arena, that both go directly to the teams here that support those competitions. And I believe we also have, you can contact us on Facebook, or there are email addresses that you can get in touch with us at as well.
So how does Mathworks see their mobile MATLAB app being used in the industry? And do you see ways that the Autodrive team members can use this app to benefit their team?
So that's a really interesting question, actually. So there is a mobile app for MATLAB that you can get on Android and iOS, and it's primarily used for like lightweight prototyping because it doesn't actually run like a full version of MATLAB on your phone, just because MATLAB takes up a lot of space. It's pretty intensive, and so it can't be run directly on the phone's processor. Instead, what it does is it actually connects to some of our servers where it runs the code on the server itself. And primarily, what we see people using the app for is actually to record data from sensors on their phones, like accelerometers, gyroscopes, magnometers, and other sensors that might be available. And you can either stream that data to a script that's running on that cloud, or you can actually log it to a file that you can then pull off onto your own PC later and process it at a later time. This is also really interesting because the mobile app actually hasn't been used heavily in industry. So it's really interesting to get this kind of question. It's mostly used in research and academia. I think a big part of this comes down to that really awesome part about being able to like grab the sensor data off of your phone is awesome when you're a student. I used it for that when I was trying to measure some stuff in a vehicle when I was in grad school. The thing in industry is usually these automotive OEMs and suppliers, rather than use that phone, if they're trying to get this kind of data, they'll actually have an onboard inertial measurement unit, or IMU, in the vehicle that they can use to collect that data. And a lot of production vehicles actually have one of these built into the vehicle. To a regular customer, or just a research lab or something, you may not be able to access the data on that. But for these OEMs, they're the ones putting them in these vehicles, so they can just access it directly. Kind of the coolest part about the MATLAB app, being able to stream that data directly, is kind of, even though it's really quick and easy to set up, for a lot of these OEMs, what they would rather do is get these IMUs bolted directly to the vehicle and kind of have them in there permanently. Whereas the quick prototyping that you would do with the MATLAB app, they can kind of get around by just having these IMUs always in the vehicle, recording from that.
So I think one of the nice things that Sam talked about is just getting that data to a server somewhere, and then all that processing on the data. So, like Sam said, a lot of times automotive customers already have a way to get that data there, but then they use MATLAB for the processing part of it. They may make a web app for MATLAB. So the automotive customers are doing some similar things with that, but using more core MATLAB capabilities than the specific app.
So, talking more about autonomous driving, what are the most powerful yet underused tools in the MATLAB and the Simulink?
Yeah, so I like this question, and what's interesting to me is I kind of have two different answers. I would say I've got a perspective on what I see in the automotive industry itself, and then I've got an answer that I would say kind of based on the Autodrive student competition last year. So if I take a look at kind of the automotive industry itself, I think it's still this driving scenario authoring capability that we have in the automated driving toolbox. So in 2017, we introduced this programmatic driving scenario object. It's got a really simple MATLAB API. You can create roads, you can add vehicles, model sensors. It's very helpful on kind of like testing the planning, controls, and sensor fusion. And then you might be thinking to yourself, well, okay, Mark, you're telling me it's been around since 2017. Why is it that it's underused? Well, a lot of what we see in automotive, especially when they're on these production programs, they will lock down on a particular release of MATLAB and Simulink, and they'll hold on to that release for a couple of years. So what we'll see is they may be locked down on something that was in 2016. Because of that, they're really familiar with that release, but they might not know about something that happened in a release after that. But my experience is when I go visit those customers and we show them our capabilities for driving scenario, then they really like it. And then sometimes that even is kind of one of their motivations to upgrade on their release. With respect to the student competition, we saw some of the student competitions actually using driving scenario last year as well as this year. So if I think of kind of maybe what is the automotive industry doing more of and the student competition is doing a little bit less on, I would say that's actually leveraging the code generation technology for the controls and the planning logic and the decision logic. So what we saw last year is many of the teams are using Simulink for part of their controls, for their closed loop simulation. But a lot of times what was actually implemented in the vehicle ended up hand coding something that was almost equivalent to it. And that's fine for a student competition, and that's there's a bunch of reasons why people might do that. But when you take a look at how industry trends go, and you take a look at the importance of simulation in designing autonomous systems, and the importance of making sure that that simulation actually matches the implementation, that's the best way to do that is through automatic code generation. So I would say students are using a little bit more driving scenario than some of the automotive companies, and the automotive companies are using a little bit more of the code generation from the student competition.
Yeah, so I also really like this question because I kind of read it as a bit more like, how do I do really well on the part of the Mathworks simulation challenge that is talking about what your team does that stands out from other teams. And I think I read it that way a little bit because that's exactly what I did, and the kind of questions I would ask when I was a student doing EcoCar. Reading it that way, I think the best answer would be it's really great to see the students actually use MATLAB and Simulink and all of these capabilities that Mark kind of talked about to actually support what you're trying to do for this year of competition. In year two, the way that the Mathworks simulation challenge was kind of structured, it was much more structured. There's a really specific task that's set out for teams to do, and for this year, it's a lot more open because really what we want to see is how teams are using MATLAB and Simulink to support the work that they need to do to meet their goals for this year of competition. My advice in that realm, having gone through a student competition, would be really kind of showcase what you use MATLAB and Simulink for. There's a lot of functionality that Mark talked about that even if it seems like it's kind of basic, like showing even just really cool plots and ways that you analyze your data using MATLAB is really awesome to see because everybody does it a little bit differently, and it really often comes out to be really cool things to see being done.
Excellent. It sounds like you guys are working on a lot of really cool technologies there. So I guess the question is, again, how can people get involved and become a part of MathWorks and have opportunities for, maybe doing like you, Sam, and grow it into the company?
Yeah, so one of the reasons we like to support competitions all around the world is we find some of the best and brightest students and we hire them oftentimes into our engineering development group. Actually, Sam, as he just mentioned, was part of a student competition at EcoCar, and we hired him into our engineering development group about a year and a half ago, and now he is moving on to the student competition team. So there's definitely lots of opportunities to join our engineering development group, to do internships, and also many of the big auto companies, such as General Motors, hire a ton of students out of these competitions. And one of the skills that these companies are looking for are that the students are able to use MATLAB and Simulink. So it's really exciting and awesome to do these. And this is an emerging area all over the world. So great competition for these students to get involved in and learn more about. You can visit careers@mathworks.com to learn more. We have jobs in engineering and computer science. We also have non-engineering roles. And we have internships, and we also have a student ambassador program where we hire students to build awareness of MATLAB and Simulink on campuses around the world. Uh, we also, if you go to our careers site, you can find a list of our college recruiting schedule. So you can check that out and come visit us. It's up to date, and you can see where we're going to be for at least the next 6 months.
Excellent. And we'll include links for that in the show notes wherever you may be listening to this. You guys have been involved here going into year three. of the competition. You spoke about a couple of things that have been discovered or firsthand experience, work with the competitions. Any extra kind of surprises or anything that you're seeing from the students or being a part of this competition, guys, before I let you go?
Coolest thing for me is that it is a competition and it is a learning experience, but I think it's also just these kind of projects are really fun to be a part of. Sounds a little bit cheesy, but the people that you work with when you do this kind of project, you really end up having strong connections with them after school. A lot of people I know at all kinds of different automotive companies are people I worked with in EcoCar. There's a lot of people that were not students and were in industry, either at Mathworks or GM or other companies that we worked with when I was a student that I maintain connections to now that I've graduated and kind of gone into industry. It's not just all about the competition. It's also really awesome just to see how it's just a really fun thing to do.
So I really like watching. So even though I'm from the tools point of view from Mathworks with MATLAB and Simulink, it's a lot of the relationships that are pretty impressive. And I really like watching the students and the mentors, especially like when they get in the vehicle for some of like the real challenges and such, and just kind of, watching the dynamics of all these people that have worked so hard to come together across disciplines. So there is this strong community piece of it, and there's a lot of soft skills in engineering that are required to work across multiple disciplines. So it's great to see the students picking up not only the technical skills but the soft skills as well.
I'm just amazed at how much smarter the students get every year just through doing this. And I think back, when I was in school a long time ago, and really wish that I had been a part of competitions like this, because I really think they build great future engineers, and they're a couple years ahead of people when they go into the workforce, versus those who didn't participate in competitions. And I've really seen that more and more over the years.
And of course, you guys have a lot of online resources for these products. Where can people find those online and get started?
So you could type in MATLAB Autodrive and you'll find a great web page that has lots of resources. It has the racing lounge. It has all the things to help you get started. You can also just type in MATLAB student competitions and you can see all the different student competitions that we support around the world and the resources that we have for them.
Excellent. Once again, we'll drop some of those links here in the show notes as well for this podcast. Thank you so much, guys, for joining us and taking the time out of your day for this. And of course, we'll see you in just a few months as of this recording for the Autodrive Challenge. Thanks, guys, for being here.
Thank you.
Thanks for having us.
Yeah, thank you.
All right. And thank you, students, and whoever might be listening in for checking out this episode of Level 4. Please, of course, subscribe on your iTunes or wherever you get your podcasts, or the SAE Collegiate Design Series YouTube page, and make sure you keep up on all the information that's coming up leading into the competition, and highlights afterwards, of course, too, or see last year's competition. A lot of videos from that and interviews about that experience. Thank you, everybody. Until next time, stay safe out there. Thank you for listening to Level 4, the SAE Autodrive Challenge podcast. Make sure you download our app on your smartphone for updates and contact information. The show notes for this episode and all others can be found at autodrive.fireside.fm.